that we have ROScribe, which is an open source tool that you can use to write your robot software in minutes. So a little bit about RoboCoach. We started the company 2.5 years ago, and my colleague Deborah is helping me. And about 6 months ago, we switched to the applications of large language models in generating software. And we have 2 open source solutions out there that you can use. Both of them, you can go to our GitHub page. The first one is GPT Synthesizer, which is generating software in any domain. It's just general application softwares. And the second tool, which is our main focus and our main tool, is ROScribe, which is generating robot softwares, specifically for people like yourself. And we really hope that at the end of the session, you guys go check it out and try it out. And this is a new tool, so there could be issues there. We love to hear your feedback. You can file issues on our GitHub. And if you use it in your projects, you can share it with us. We can put it on our website, and we can acknowledge your help with the just running the software and creating a demo, or if you want to even contribute to the project, you can do that. So what is it that ROScribe does? ROScribe can help you learn ROS. If you're new to it, ROS could be intimidating. There are a lot of things you may not, it may take you a while to figure it out. So we think that if you use our tool, it can help you to see how things fit together. This is an example of a ROS graph that you can see here with the ROS nodes and topics. So when you use our tool, we generate this for you, and we let you modify it, add something, remove it, so you can get an idea of how it looks like in ROS. And then we generate all the softwares necessary for all the components. And you can play with it, you can modify it later. So the idea is that it should help you learn ROS. And we want you to adopt ROS for your project because it's the most common standard for robot softwares. And it's also growing in popularity. It's even finding its way in IoT, Internet of Things. So it's gonna stay, and it definitely worth the effort to learn it, and I think our tool should help with that. And if you're familiar with ROS, still the software can give you a blueprint for your software, meaning that you can have a first draft of your software generated automatically in minutes instead of figuring it out in months. And then you can probably modify bits and pieces. Maybe you change one of the codes for one of the ROS nodes, and maybe you have your own code. You want to replace it with the code that the language model has generated for you. The way I see it, I think probably the most common way you could use it if you're a student of robotics, and let's say you're working on a new solution for a mapping. And you build your own code, and that's your research, you work on it. But then when you want to actually put it in the entire system, in an actual robot, or for simulation purposes, you need all the other components, right? All the other components that the other sensors and actuators, and that's where ROScribe can be helpful. You can build the software quickly and just focus on the components that is your research. ROScribe uses language models for software generation. We are using OpenAI's GPT 3.5 as the default, but you could change it, especially because we are open source. You can modify the code if you want to switch to any other language model. And we are supporting both ROS 1 and ROS 2. Currently, we are only supporting Python. We don't support C++ for the code that we generate, the code that LLM generates. It's only in Python, but we're going to add the support for C++ later. I want to take a few minutes, talk about a little bit about the philosophy of what we are doing. I want you to understand that why is it that we are using a language model for code generation. So the first question coming to mind is that language models, by definition, are made for human languages, right? They understand, they are really good at understanding when we speak. They can read between the lines, they can extrapolate from what you're saying. But Python or C++, these are not human languages. So a fundamental question is that, is LLM really the good approach? Is it an overkill? Why do we use LLM to generate Python? So to answer this question, I should mention that there are two sides to code generation. One is generating the code, which is, yes, in Python, and it's not human language, it's the structures, it has semantics, you don't need necessarily a language model for that. But there's another side, which is the specification. And that's where human language comes handy, because still you have to specify what you need. The specification, the intent for your software, is where the language model is at its strongest suit. And that's where the focus of our work is. If you look at our code, both in GPT Synthesizer and in ROScribe, you can see that probably 80%, 90% of what you're doing is on capturing the spec, not necessarily in code generation. And we also ask a lot of questions when you run. We're going to show you a demo later on. You can see that the software asks a lot of questions because we want to make sure that we capture all the details from user. And we want to make sure that the user is in the driver's seat. And ultimately, it's not the LLM that generates the software. It's the user, it's the human using the LLM that designed the software. There is another way to look at it. If you think about the computer history since the beginning of the dawn of computers, we as humans, we always created languages as a way to communicate with computers. And the only reason was that computers couldn't understand us. There was no other way to describe what we need, right? So it all started from zeros and ones, and then quickly assembly language. And then we tried to go one level higher, right? So we had basic Pascal, C, C++, and then we relied on compilers to translate it down to the assembly language. And this quest for higher levels of abstraction continued with Perl, Python, with MATLAB, all these other languages. But today, recently, for the first time ever in computer history, they can understand us the way we speak. So we don't need any other mean to communicate with machines other than human language. So what I expect to happen in the future is that all these languages will go to the background. They still exist for legacy reasons because there are a lot of ecosystem around Python or other languages. There are all sorts of softwares. But the interface between human and the machine would become human language, and then LLM can translate it into the Python or whatever language there is. And a lot of times I hear people say that LLM replaces a software engineer, doing that, which is a fair thing to say. But the way I see it is that it's not the software engineer being replaced by the LLM. It's that the human language is replacing Python or replacing C. Still human is in charge. And we still want to keep human in the driver's seat throughout the softwares by asking a lot of questions, gathering all the necessary information before generating the code. There is also a point I want to make when comparing code generation in a general domain versus a special domain. So when we are focused on a specific subject, say robotic in this case, the attention of the LLM can be focused specifically on that subject. So it means that the language model, the GPT, it's less likely for the GPT to get confused or have hallucinations or issues with generating, and they can have a much better output, much cleaner software generates. And it also depends on the quality of your prompting, because And if you try the software, you will see it. Your input matters. With what you tell the LLM and what internally we are basically feeding LLM dictates how good the output will be. So let's go look inside how ROScribe works. So the first thing when you run the tool, by the way, right now we don't have a graphic user interface like this for the tool. It's a command line interface, but that's something that we are considering that maybe we add something. We have it for GPT synthesizer, and we're going to hear feedback that if you think having a graphic user interface helps, we could add it. So when you run it, first you provide a general task, what it is that you want to do, and also you tell what ROS version you want to use, ROS 1 or ROS 2. And then the software asks you further questions, a few high-level questions to see what is the overall picture of the design that you're describing. So we are capturing enough information, and we are basically feeding the chat history plus the top-level information to a prompt generator engine to create a prompt, push it to LLM to create the follow-up question. So we continue this cycle until everything is clear. And when everything is clear, we can show you the ROS graph. And we also let you modify the ROS graph by removing or adding a ROS node. And this is now the top level done. Now we go to every ROS node and we want to generate the code for those. Again, there are a process of almost like an interview process that the AI takes control. It kind of holds your hand, walks you over the design space, shows you different issues that you want to make decisions on. It asks you, what should I do here, what should I do there? And you provide these answers. And we feed all this communication with top-level information to the LLM, generate the next question. And when everything is clear, we generate the code for that ROS node. And then at the end, we also generate all the necessary files that you would need for ROS, for installation, for the launch. They are all generated here. So this is one approach, and this is the current release that we have basically generates the code the way we just explained. But there is another approach that we have implemented. We haven't yet merged it into our final release, so this is going to be our next release. And this is a technology called RAG, Retrieval Augmented Generation. This is a very edgy, it's on the basically state of the art of how using LLM for software generation. And the main point here is that instead of really using LLM to dump the code, because we just talked about how LLMs are not the perfect tool for the code generation. They are good for capturing the state, but when it comes to generation, the output may not be the best. So another way to do it is basically having the LLM to pull out those information from online databases. So specifically in this case, ROS index. So what we do, we put all the information in ROS index into our LLM, meaning that there are a lot of documentations, there are a lot of meta information. We put them in vector database. And if user wants to implement something, you want to do a mapping, you communicate to the ROScribe and you say that, yeah, I want to do this. And then we do a query into the database and see what is the best match that we can find. You can even ask questions on, what features it has. So basically, we are turning the ROScribe, we are turning the LLM into a robotics expert. So it's like you're talking to an expert who knows everything, all the codes written in ROS index. And so you can ask about, what is the best solutions available for this purpose. And then when it generates the code, it pulls out those code from the actual repositories, because everything's open source in the ROS community. So we create the software based on the information that's available. So the code's not generated by the LLM, and it kind of guarantees that it's the most optimized, it's the best code. but the communication handled by LLM, the database handling, LLM is like a robot expert that handles all the questions you have and then bring the information from ROS index and creates your software. It may generate some code, but bring some of the codes from the online repositories. And that's retrieval augmented generation. And we have two demos here that I have Behra show to you. So before I hand it over, one is the RAG demo, one is the other demo. We also have a link to our repository. So make sure that go there, check it out, give it a try, and hopefully you like it.
All right, so first I'd like to demonstrate the RAG feature that Said just described. Yeah, go ahead.
When you ask it to build software, can you go back and say, I don't like that, can you change this?
At the phase where you're describing your ROS graph, you're allowed to modify it. But once you've started, let's say it's already selected a node, during that conversation you're allowed to give as much information as you like. But once it's generated the code about that particular node, currently it's not capable of going back and modifying it. But that is also another feature that we're exploring.
Yeah, something that we hope maybe in the future we enable. Right now, during the specification you can say anything, right? But when it's done, it's done. But in future we want to keep the software running. When everything is done, then ask the LLM to modify this part, that part, and the software be live. Or maybe even feed a code that you already generated from before, regardless of R2, maybe you already have a code base and upload it and kind of work with it.
Go ahead.
Is it so after you sort of have it generate your code base and then you're running it and you get some errors,
Mm-hmm.
do you have the capability to ask, like, these are the errors that I'm getting, where do you think this is coming from?
Mm-hmm.
Like, how do I debug this?
Yeah, that's also another excellent feature that we're exploring right now. At the moment, no. So currently it generates it, and in the ideal case, it's something that's out of the box. It just automatically runs.
Right.
There are instances where you will have like minor things that you need to fix throughout the code, but the idea is that if you wanted to start this entire project by yourself from scratch, that would have taken a greater amount of time to do versus like trying to debug features.
Right.
But like the RAG feature is something that's, I think, very valuable like from in the early phases too, because if you're trying to explore something, let's say you have a particular project that you want to do, you want to know what are the pre-made codes that are currently available to you, like all the ROS packages that are useful for your particular project. Since we're parsing the ROS index, it will give you the best package that's suited for your particular project. This demo should kind of paint a better picture. All right, so the first thing that it does is that it greets you and it says, well, what would you like to do? And then you say, I want to find a ROS package. Can everybody see this? It's for multi-layered grid mapping, right? And then it goes and looks over that database that we've collected in the earlier phases, and then it says, I found the grid map package that's looks like it's suited for what you want to do, and it also provides a link. And then you ask it for additional information. You're like, hey, can you describe this package a little bit more?
By the way, these demos are available on YouTube, so you could later on put another one that's a little bit small here, or
Oh, it's difficult to see. Yeah, so it gets some like key ideas about the project, such as like multi-layer grid mapping, efficient map repositioning, IGIM integration, and then let me see if I can speed this up.
This is the part that you're talking to an expert. You basically have questions that with this mapping that you want, what features it has. And all the information comes from ROS index, so basically LLM processes it.
So now that you have your, sorry, go ahead.
How did you get the link in?
Yeah, so like that's the entire point. Like let's say that you didn't have this tool, right? You would go on to the ROS index and you're like, all right, let me see what package is useful for me, right? And then it provides you a link to their GitHub repository. This is essentially an agent that can go and parse that entire index for you immediately and only extract the ones that are useful for you. So that's where that link comes from. It's from the ROS index. And then, so now that it gave you the package, it gave you some additional information. You say, hey, I really like this package. Can you show me how I can install it? And does it have Debian installation? And then it says yes, and then it provides you installation commands such as like sudo apt update and then sudo apt install ROS, whatever distribution you're using. And then now that you have the package, you're kind of curious. You're like, are there any demos for this package? And then it'll parse through the package and explain, like, these are some of the demos that are available. There's the grid map demos. There's the grid map loader, the grid map cost map 2D, whatever other demos that are provided by that package. And then you see that there's a filtering demo, so then you're like, I'm really interested in this demo, can you tell me how to run it? It gives you commands on how to run it, and then it says what are the environment requirements that you need in order to run this. And now that you say, oh, I want to run this one, but I actually want to run it in ROS 2 instead of ROS 1, so how should I proceed? And then it gives you, again, another set of instructions on how to run it in ROS 2. And now at this point, you're satisfied. You got whatever you needed. You found the package that you like. So now it's a matter of validating what it gave you. So you're going to run the commands that it gave you and see if it's able to give you the demo that you were looking for. And for the sake of time, let's skip some steps. This is just running those commands. And then after doing a ROS launch, this is the demo. Okay, so that's RAG, and then
just a sec. Can you do?
And I can very quickly kind of fly through the demo for this.
Oh, okay.
Yeah, this demo doesn't use RAG, so this is the one that we currently have as the latest release. So this is where the element generates all the code without retrieving anything from the base.
Yeah, so I'll go very quickly, but the idea is that you want to have a turtlebot simulation where you can put in keyboard commands to just change directions. And then once you do that, it recursively questions you just to get a bigger picture of how to graph that ROS graph that Said mentioned in his presentation. So this is the ROS graph that initially comes up with, and you think to yourself, you're like, you know what, this doesn't really look like what I actually want it to look like. So you kind of like communicate with it, and then you modify some of those nodes, and then it generates a new graph, and now out of those two nodes, you kind of like describe the functionality that you want them to have. So this is kind of like asking you, what do you want those nodes to do? And then you run the code that it generated, and you see that, voila, there is your turtlebot. All right, any questions? No? Everybody knows everything? Yeah, go ahead.
So the previous demo that you showed, I mean, the interaction was very similar to as if I'm just working with ChatGPT.
Right, that's fair.
So, what's the main difference? Like, what's the benefit of using this versus ChatGPT?
Yeah, so like, it's that RAG aspect of it. When you prompt ChatGPT, like when you go to the website and you ask a question from ChatGPT, the idea is that it's trying to extract information from its initial training data, right? It doesn't have any specific information about ROS. It's not up to date. It's whatever it was trained on. If any ROS information was given to it, what we're doing is we're extracting the most recent information available about ROS from this website, and we're feeding that as context to the LLM. So whenever you ask a question, all of the information that we extracted from the ROS index, we've stored it in a vector database based by context similarity. So we're using OpenAI's embedding, where they embed it based on context, and then that's how you're able to later on retrieve the most relevant information and feed that as an initial information to the LLM before you ask that question. So the fact that we have most recent relevant information about your question is the differentiation between just using ChatGPT.
Are you fine-tuning GPT models for that?
No, we're not modifying that. The LLM is like out of the box as it is. It's just feeding it context.
But doesn't like the prompt size explode because the ROS index is a huge.
Right. We're not. We don't feed the entire ROS index. Like as I said, they're stored based off of context inside of a vector database. So it's essentially it's like a k-nearest neighbor. You find the most similar information based on your query, and then you extract only that relevant information. You don't feed the entire index.
Database of vector index.
That's right.
Okay.
Do you have a demo of the code commands you use hardware?
No, that's a really. We actually don't have robotics hardware, so maybe that's probably why we didn't think about that. But that could definitely be another demo we could add on to the GitHub. If you guys get a chance, definitely check out the GitHub. There's a link to also GPT synthesizer, which is like generalized code generation. So let's say you want to make like a personal portfolios to like demonstrate all your projects. Like you don't want to go and learn HTML, CSS, and like JavaScript all over. You can use GPT synthesizer to like kind of like make the web page that you're interested in. Yeah.
So you've embedded both the ROS1 and ROS2 documentation with the databases?
Yeah.
Cool. Are you also going to do like the ROS answers forums as well? Are those part of the?
No, not currently. I think currently it's just the GitHub repository.
Okay.
Yeah.
But I guess that's something that can be added, because that's information in human language, and if that's something useful, if that helps us to figure out what code is more suitable for what problem, then
That's where people go to debug,
Yeah.
right? They go to ROS answers to find out what the errors are. So unless you're going to find like Stack Overflow, right? The other place you're going to go is ROS answers.
Right. That's a really good point. I think like right now the most obvious answer was ROS index.
Yeah.
The goal is to kind of like expand to additional resources. I think some of the things that need to be considered is like how accurate is that information. So like just reading the entire forum, like how many of those stuff are relevant, and also like how does that scale in terms of like the total amount of information that you have. So it's like when you install the package locally, like you're kind of like storing that entire information onto your laptop. So it's like, do you want the user to kind of like download 100 gigabyte of information, or is that something that's going to make them weird about wanting to use your application? So I think these are things that like kind of like constrain us about like how quickly we want to like run to additional resources, but like ROS answers definitely would be like another best possible avenue.
Do you have any guarantees that the code that you generate is either A, 100% source form, something that is in ROS index, and 2 is not malicious?
So the ROS index is just the RAG aspect of it. It's the advising. So it doesn't write any code for you. It advises you on like what packages you should use and what are some features that are useful for you. For example, like it gave a particular package, and then it gave all the demos that are coming with that package. The ROScribe part without the RAG, because these two aren't actually related at the moment. Like the idea is to kind of like integrate the RAG aspect of it kind of like revalidate the ROS code that is generated from ROScribe, but at the moment it's purely what the LLM understands of ROS code. It doesn't have any information from the ROS index. So there is no guarantee that all that information is from the ROS index, and I think any malicious code or any security feature that would prevent any malicious code is whatever the OpenAI LLM already has available. So there's no additional layer that's implemented by us.
I think also this is the responsibility of the ROS index. You know, if you are pulling the code from ROS index to put into the solution, we can guarantee that the code come from ROS index, or some of the code come from ROS index, some of them will be LLM generated. But the part that comes from code index, it's the vetting happens on their side. We don't do any vetting on top of that. All right.
Very nice.
Thank you very much. Thank you.
Just kind of like a quick feedback, I'm kind of curious, who likes the ROScribe more and who likes the RAG one? Like, which one do you think is more helpful in terms of like your day-to-day ROS usage? Or are they both just like